In this lesson, we're going to be dividing radicals. We're going to simplify a root that has a fraction in the radicand, and we're also going to learn how to do something called rationalizing the denominator. Remember the three rules. There can be no perfect squares in the radicand, no radicals in the denominator, and no fractions or decimals under the square root. Let's take a look at some examples. So if I have the square root of a divided by the square root of b, if my a is 4 and my b is 49, I can take the square root of each of these separately. I can also write it as one radical, 4 over 49, and take the square root, which would be 2/7. So I can take the square root of the fraction itself, or I can take the square root of the numerator and then take the square root of the denominator. Let's do another example. So if I have the square root of 36 and I have the square root of 4, the square root of 36 is 6 and the square root of 4 is 2. And then obviously that could be simplified to 3. I can also take the square root of the fraction as it is, 36 over 4, which would be 6 over 2. And this can be simplified to 3. Let's try one more example. Let's take the square root of 25 over the square root of 36. I can take the square root of each the numerator and denominator separately, or I can take the square root of the fraction as a whole. 25 over 36 would be this 5 over 6 when I take the square root. Another thing we have to remember is that when we are taking the square root times the square root, because they are alike, we can multiply them together. And then 3 times 3 is 9, and the square root of 9 is 3. So essentially what we were doing is we were taking a radical times itself, or squaring it, and since they are opposite operations, we're going to end up with what was under the radical to begin with. So the square root of 5 times the square root of 5 is the square root of 25, which simplifies to 5. The square root of 8 times the square root of 8 is the square root of 64, and that simplifies to 8. The square root of 156 times the square root of 156, well, I think you're going to get the idea that when we're multiplying it times itself, we're squaring it, and square and a square root are opposite operations, so we're going to end up with the original number. So we have a times a, which is a squared, and the square root and the square are opposite operations, so that's going to leave us with a. That's going to be an important concept as we move on to our next topic, which is called rationalizing the denominator. This is a way for us to get rid of the square root in the denominator. Here's how this works. We are going to multiply the denominator times itself. When we do this, a square times a square is going to be the square root of 4, which we know the square root of 4 is 2. But when you multiply that value times the denominator, you also have to multiply it times the numerator. And 1 times the square root of 2 is the square root of 2. This then is the simplified version of 1 over the square root of 2. We don't have a radical in the denominator any longer. And essentially what it did was to simplify, changing the appearance but not its value. Because if you recall, any number divided by itself is 1. So we've simply multiplied that expression times 1 in order to simplify. To rationalize the denominator, you simply take the radical in the denominator times itself, but don't forget to multiply it also by the numerator. So 1 times the square root of a is the square root of a, and the square root of a times itself would be a squared, and the square root of a squared would be a. Now it looks like in both of these examples that we could simplify, but remember, you can't simplify if 1 is in and 1 is out. So these are not the same values, we can't simplify any further. This is the simplified form for 1 over the square root of a. Let's do some more. So we have 2 over the square root of 5. So I want to get rid of the radical in the denominator. I'm going to multiply both the numerator and the denominator by the square root of 5. 2 times the square root of 5 is 2 square roots of 5. And the square root of 5 times the square root of 5 is the square root of 25, which is 5. I'm going to multiply both the numerator and the denominator by the square root of 3. So we have 3 square roots of 3 over the square root of 9, which is 3. But now we need to finish simplifying because both the numerator and the denominator have a 3 that's outside the radical. 3 divided by 3 is 1, so my final answer will be the square root of 3. In our next example, we have the square root of 8. And there's a couple ways we could do this. We could make a factor tree first to simplify the 8, or we can simply multiply both times the square root of 8 and then simplify later. So we have 2 square roots of 8 over 8. We can simplify the 8 to be a 4 and the 2 to be a 1. So we have the square root of 8 over 4. But we should make a factor tree for 8, which is 4 times 2 and 2 times 2. That's going to leave us with 2 squared under the radical, so we can bring a 2 outside, and one of the 2's needs to stay underneath, and our denominator is still 4. So to finish simplifying, we can divide these both by 2, and our final answer will be the square root of 2 over 2. Alright, we did talk about from the beginning that you can simplify first a fraction that's underneath the radical as long as they're both underneath. So if I were to simplify 4 over 24, 4 goes into 4 once and into 24 6 times. Then I can separate the numerator and the denominator. The square root of 1 is 1, and we still have the square root of 6 in the denominator. We need to rationalize the denominator, which means we're going to multiply both of these by the square root of 6 because we can't have a radical in the denominator. 1 times the square root of 6 is 6, and on the bottom we have the square root of 6 times the square root of 6, which would be the square root of 36, or the square root of 6 squared, and that simplifies to be 6. In our next example, we cannot simplify 3 over 20. So we are going to make a factor tree first and show you that method for 20. 4 times 5 and 2 times 2. So we have the square root of 3 over, and remember the 2 can come outside because it's 2 squared, and then we have the square root of 5. So now we need to rationalize the denominator. We're going to multiply both the numerator and the denominator by the square root of 5. The square root of 3 times the square root of 5 is the square root of 15. And then we have 2, and this would be 5, so we have 2 times 5, which is 10. Remember, the 15 is under the radical, and the 10 is outside. They are completely different numbers. They can't be simplified any further. We have the square root of 12 over the square root of 125. Now, can we simplify those to begin with? Let's make our factor trees. We have 4 times 3 and 2 times 2. So the 2's, one of them can come out and the 3 stays underneath. 125 is 25 times 5 and 5 times 5. So a 5 can come out and the 5 stays under the radical. But we still have to simplify by rationalizing the denominator. We need to multiply both the top and the bottom by the square root of 5 to get rid of the radical in the denominator. So we have 2 times the square root of 15. Since the 3 and the 5 are both radicals, we can multiply them together. And then we have 2 5's, so we're going to multiply those. It would be 5 times 5, which is 25. Taking a look at our next example, we can simplify by using a factor tree, 9 times 3 and 3 times 3. So one of the pairs of 3's can come out, so we have 3 square root of 3. And a factor tree for 20, we have 4 times 5 and 2 times 2. So the 2 can come out and the 5 stays underneath. So to simplify, we're going to multiply both the top and the bottom by the square root of 5. So we get 3 square roots of 15 over 2 times 5, which is 10. And again, the 15 and the 10 are not alike, so they can't be simplified. So let's review. To rationalize the denominator of the fraction, remember you're going to multiply both the numerator and the denominator by that radical. Please remember that a square root times itself is simply that number. Please remember to complete the reflection.